All right. So the question is basically it says I have to find the real roots of, and then it's a function.
Hmm.
Basically, the function is kx equals to x minus 7 root x.
Kx, say it again, minus?
Sorry, no, my bad. Sorry, so the function is actually k and then brackets x rather than f of x.
Ah, so the k of x is equal to,
Um, is equals to x minus 7 root x
yeah,
plus 10.
okay. Um, any idea how you do it?
I thought I had to like times that by x,
Yep, that's it.
and and then if I get x squared, the thing is, I didn't know what minus 7 root x times x would be.
Um, minus, oh, I see what you're saying. Hang on. Instead of, there's another way to do this. What if you said let? So let, um, uh, let's say x to the half. So root x is x to the half.
Yeah.
Oh, I'll just leave those root x. We'll see how we go. Let root x be equal to a. So what will
Okay.
happen there?
So then it would be x. So would it just be ax then?
So root, if root x is x to the half,
Yeah.
so x by itself is to the power of what?
1.
So that's x to the 1. And so um, how does that compare to x to the half?
It's two times x to the half.
And so x to the 1 is the same as a to the 2.
Right. Okay. So does that mean that I need to make x a squared
Mm-hmm.
and then minus 7 x to the half?
And what is x to the half same as?
Um.
What are we letting it be?
Oh. A
Mm-hmm.
minus 7a and then plus 10. And
Yeah.
then I'd just do the polynomial thing here.
Yeah. And
Okay.
you want the roots, so that's when it's equal to 0.
So 1 minus. So I got 5 and 2 as the two x's here.
And so technically that's the two a's. A is equal to 5 or a is equal to 2.
Yeah.
But so we weren't asked for a, we were asked for x. So what do we do here?
Do I now have to square root that?
So we would now like unlet.
Oh, do I have to square root?
Yes. So
So
root x is 5 or root x is 2. Yeah. And so x is,
25 or 4.
yeah.
Okay.
And that's it. And so that's quite a common one where it's a quadratic in disguise. Usually you have x squared plus x. Well, let's say it's x squared minus 7x plus 10. That is the same as x to the 1. And so it's x to the 2 and an x to the 1. And there's also an x to the 0 that's just a number. But basically, if you have one of these is double the other, then that's a quadratic in disguise. So if you have x to the 1 minus 7x to the half, then that's still double of the other.
Yeah.
And so it's just a disguised quadratic. And you always let the smaller one be equal to some dummy variable just to help you to solve it, and then you unlet it back. You can do it without the let thing, but it's just it's a bit more straightforward, I think.
Okay.
Any questions there?
No, thank you. Yeah, okay.
Okay, let's see. Okay, and we might be using them. Okay, how do we do these? How do we do A?
So so do I just need to do 5x minus x is greater or equals to minus 9 plus 20? Be 4x is greater or equals to 11. And then x is greater or equals to 11 over 4.
Yeah,
and
that's grand.
Yeah.
How would you do C?
It's just expanding it, isn't it? And then just doing the same thing.
Yeah. Let's see. So from GCSE, you saw these number lines. X is greater than minus 2, so open circle like that, and then x is less than or equal to 4. What are the integer solutions here?
Of x. So is it 4, 6?
Hold on. 6 is more than 4. X is less than or equal to 4. So it has to be values of x that satisfy both.
Right. So will it be 0? Oh no. Oh yeah. Will it be 0, 2, 4?
Yeah. So there's also, they just didn't write them in.
Oh, so yeah. So 0, 1, 2, 3, and 4.
1, 2, 3, 4. Any others? Why not minus 2?
Oh, minus 1 as well.
Yeah. So minus 1. Great. And so, yeah, that's how we do these. Okay, this time we've got 3 sets of inequalities. Does this change anything? What are the integers? Oh no, sorry, that's what it is. So when you put them together, that's what it looks like.
Okay.
Okay. Let's see. So for this one, there's no overlap. So this is just the way it is. This is just the solution. Okay. Okay, how do we do A for this one?
Okay, so I'm guessing, do I need to solve for x for both of those equations? Okay, so for the first one, will it be, so 3x minus x is greater than 5 plus 8. So then 2x is, oh no, sorry. So then 2x is smaller than 13. And then x is smaller than 6.5. Wasn't there something like I have to switch around the sign or something like that?
Only if you multiply or divide both sides by a negative.
Oh, okay. All right. So yeah, and then for the other one, so 5x is greater than x minus 8, and then 4x is greater than minus 8, and then x is greater than minus 2. So basically, I've got here x is smaller than 6.5 and greater than minus 2. So will it just be minus 1, 0, 1, 2, 3, 4, 5, 6? Oh,
Yep. Those are the integer values, and you can also put them together.
yeah.
And what is it? If you're asked for, no, we'll get there. Another way of writing it is if you did x such that, and then curly brackets around it.
Yeah.
Okay. So that was -2 to 6.5. They're going to be fine. I think they're going to be fine. I think they're just getting silly in there. Yeah. Let's see. Use set notation for these. So this down here is the set notation. X such that. Oh, sorry. Hang on. The curly brackets are around everything. So X such that, and this left curly bracket is around the X. Use set notation. So that is that, and that is that. So I think those are okay. Just put curly bracket X such that, and then curly bracket at the end, and your answers as normal. In the middle. Yeah. Yeah. So that one's a bit strange. G. Let's see. Aha. X is less than 6.5. So this one, what is this? Question F. So the solution for F is X is less than 6.5 and X is, 6 over 5 greater than 11 over 5. Any idea how you do that in set notation?
So 6 divided by 5 is 1.2.
Right.
And 11. So, oh wait, does that actually matter or not really?
No. Okay. X is greater than 2.2, is it?
Yeah.
And then how do you put that into set notation?
So when I do curly brackets,
Yeah.
and 2.2. Oh no. Yeah, 2.2. Then
Hold on. So curly bracket, X such that.
yeah.
And with this one where there's two separate ones, we put it there. And then same for this one. So what will this do? How will you do for this one?
So it'll just be curly brackets, X notations again, or
Yeah. X. Then what?
the little
Such that.
yeah, and then the curly brackets to finish it off.
Yes. And because these are two separate ones, the way we do OR is that U-shape union. Either or. Let's see. Yeah. Okay. Any questions there?
No.
So it's just about remembering those things. So that's linear inequalities. I'm just going to say that's grand. Okay. How do we do this?
Is that just quadratic formula?
Yeah.
So -2, -5, 3. So I've got half is smaller than 0. Oh no, and then oh no, sorry. So it's meant to be x is a half or x is -3. So does that mean it'll be like it'll be the curly brackets
Hold on. They didn't ask for that notation. The other thing is you did the quadratic. You could draw a graph and the whole thing. You know when you go menu?
Yeah.
This time go to B. Inequality.
Okay. Yeah. Oh, yeah. And then I do the second one, don't I?
Yeah.
Yeah. Oh, jeez. Yeah. So I got x is smaller than -3, comma half, then which is smaller than x.
And so flip the second one around so x is on the left side. So instead of it being a half something x, make it x something a half. What goes in the middle?
Oh, it'll be the other way. The sign will be the other way around.
Yeah. And those can't be put together. So let's imagine that they asked for set notation. What would it be?
Sorry, what do you mean?
The curly bracket stuff.
Right. So will it be? So open the curly brackets, and then x, the two dots, and then will it then be half?
Nope.
Then
these can't be put together.
what?
-3 is smaller than a half.
Right. So it's got to be. Will it be x and then minus the sign, then -3? And then it'll be the same thing. Oh, sorry, close the brackets. And then will it just be the same thing like the other way around? Just the same one in the half and stuff.
Yeah, there is something missing in the middle. How do you say either or?
The or thing.
Yes.
Yeah.
You for the union of them. That's it. Great. Any questions there? Okay. And so here's how people used to do it. They used to sketch a graph, and they used to say the graph is above 0 between here and here. Now we're just using calculator. Okay. How about this one? Question 6.
Am I doing the inequalities thing on the calculator?
Yeah.
Again.
Just calculator.
Yeah. So. So I got -2 is smaller than x, and then x is smaller than 7.
7.
Yeah.
So get x on the left side for both of them.
So x. So it'll be x, and then the little sign up the other way around, and then -2.
Yeah. X is less than 7. And what would this be in set notation?
Okay. So will this then be? So open the brackets, and then x, two dots, and then x is greater than -2.
So what do you know if x is greater than -2 and less than 7?
It's close. Oh, so it actually makes sense. So will it then be -2, and then the -2 is smaller than x, which is smaller than 7, and then close the brackets.
Great. That's it. Now, they didn't ask us for that notation, but I'm just practicing.
Okay.
Hold the phone. Hold the phone. Did you put this into the calculator wrong? That's greater than 0. Did you not put in greater than 0?
Oh.
Menu, inequality.
Oh no, I didn't do that. No, sorry.
Okay, so what is it? 1 minus 5 and minus 14. Okay. X is less than 2 and X is greater than 7. So it would have just been the same as the stuff before. I'll just change that to a less than for us. But we've done both types of index notation. Okay, this is a good one. Let's try it. Question A.
So A is minus x squared plus 4x plus 12 is greater than 0.
Mm-hmm.
And then that'll be minus 4. And then so it gives me minus 2 is smaller than x, which is smaller than 6.
Mm-hmm. Part B.
And value solution. So for 5x minus 2, so that'll be x is greater than 1.
Yep.
And then find the set of values. So will it just be 2, 3, 4, 5?
Those are the integers. So just in general.
Will it be 2 to 5?
Again, those are the integers. So what would it be without the integers? Just using their way of writing it.
2.
No.
Will it be 1 and then 1 then is smaller than x, which is smaller than 6?
Yeah, that's it. And that's why they were doing that number lines thing earlier. And so it's 1. So basically x is between 1 and 6. And
Okay.
I was just doing the integers earlier just to kind of clarify it. But basically x could be 1.5.
Yeah.
It could be 1.1. There's nowhere that says it's an integer. And so we just have to go with it. You did great for that one. So I'm going to skip over these. Set notation. Okay, let me just see the set notation. Oh wow, that's weird. Some weird stuff. But it's the same thing with the set notation. Alright, this is an exam question. It's probably weird, but let's do it.
Okay. So the first one, so for A, I got x is smaller than 1.5.
Okay.
And so do I just go on to B now?
Yeah.
Okay. And then I just need to do the polynomial thing here. Oh no, not polynomial. Well, it's on the integers thing. And then
inequalities thing.
Yeah.
Solver.
And then that'll be 2. And then I got minus a half is smaller than x, which is smaller than 3.
minus a half smaller than x smaller than 3.
Yeah.
And I believe part A is actually 2 over 3, not 3 over 2. Am I crazy?
I hope. I don't know. So 6x minus 2.
You have to add 3x to both sides.
Yeah.
So I get 9x is less than 6.
Yeah.
Okay, and so what is question C?
Oh, right, yeah. 6. And then both 2, 4. Oh, right, so set of values. So, is this what I have to do it like, in a more like general way? Or do I? Okay, so is it just do I have to do 2/3, and then it's smaller than x, which is smaller than 3?
Yep, that's it. Right.
Okay.
Oh, did they ask for set notation? Maybe they did. So x is such that hold on. That's between minus, let me see, b. Minus a half to 3. X is smaller than 2/3. Oh, 2/3 and smaller, not 2/3 and bigger. Ah, we're wrong. X isn't bigger than 2/3. X is smaller than 2/3. So actually, what does that tell you about the final answer?
That's going to be separate. Or
It tells us, so if we were to do it like this, so we have x is less than 2/3 and x is between here, and so what set of values satisfies both?
0.
No, not like that. The like set of values, so between what and what. So you might say, well, x you might say x could be -2, but it can't because that doesn't satisfy the second one.
So,
Or x, like, could x be -1?
no.
No, because it doesn't satisfy both of them. And so what values satisfy both?
Would 1?
Yeah, and well, no, 1 wouldn't satisfy the first one. But yeah, and so what values satisfy both?
Okay, alright. So, um,
And they don't need to be whole numbers.
0.5 minus 0.7 or something. I don't know.
I think it was -0.5, -0.5 from part B. So they just drew part B.
Oh,
So that's -0.5.
and then what would the last number be? 2/3.
Yes, and so that satisfies both. And so x is between -0.5 and 2/3.
Okay.
Yes, so this time it was the upper bound that was made lower. Any questions there?
No.
Okay, so x, we knew x was between -0.5 and 3, and we also knew that x was less than 2/3, and so if it's less than 2/3, then it couldn't be 1 or 2 or 3 or any of those, so it just had to be less than 2/3. We could practice that a bit more. Wouldn't mind doing one more. Just want to pick one here. Can I see? Oh, that's a bit. Yeah, let's do. Okay, let's try question C.
Okay, so so I need to do the inequality calculator thing for C for the first bit, and then that will be minus a quarter is smaller than x, which is smaller than 1.
Okay. And second part of it.
And then so I got x is smaller than 0 for the second bit.
Let's see. 4. Did you add x to both sides? Get 5x?
Yeah.
So how did you get 0?
I did 5. I did 50 minus.
Yeah, you're right. 5x is less than 0, isn't it?
Yeah.
Okay, so x is less than 0.
So, and then. So, does that mean that. So, will it be minus a quarter and then it's smaller than x, which is smaller than 0?
Great, well done. Any questions there?
No.
Grand. So that one got rid of the upper bound, made the upper bound lower. And there's some tricky ones in there, but it's all the same really. So x a half a tick, quadratic inequalities.
A tick.
Grand. Okay, now it's time for weird stuff. How do we do this?
So is x smaller than 3?
Okay, you would think so. So x could be smaller than 3. So if x was, what number is smaller than 3? 2 is. So 6 divided by 2 is 3, and 3 is greater than 2. But what else could work? 6x. What if you multiply both sides by x? What do you get? Sorry, multiply both sides by x squared.
So 6x squared is greater than 2x squared.
Well, it's 6x squared over x.
Yeah, so 6x squared over x is greater than 2x squared. Oh, and then divide, and then what? So make it so 6x squared is greater than 2.
Simplify. So what is x squared over x?
Oh, no, sorry. Will it be 6x squared is greater than 2x? Or
What is x squared divided by x?
x?
So 6x squared over x is the same as 6x.
Yeah. So 6x is greater than 2x squared.
And then solve that.
And then I could do quadratic formula, couldn't I?
Yeah.
So 0 is greater than 2x squared minus 6x minus 0 or plus. And then I got 0 is smaller than x, which is smaller than 3.
So we initially said x is less than 3, but now we're saying that x is less than 3. Ah, yes. Why can x not be less than 0? Why can it not be minus 1?
Is it because x squared is never negative?
Yeah, and if you go back to the original question, what happens if you divide by a negative number? What if x was minus 1? What would you get?
You just get a positive number.
What is 6 divided by minus 1?
Minus 6.
And is minus 6 bigger than 2?
No.
No. And so instead of the answer being x is greater than 3, it's actually x is greater than 3, but x is greater than 0. Sorry, x is less than 3, but x is greater than 0 because it can't be negative. And so it's between 0 and 3. And a way to calculate that is to multiply both sides by x squared because it can't be negative.
Okay.
So I'll try it out. Oh, this is weird stuff. Let's just do, I don't know. Do you want to pick one?
The first one, I guess.
Yeah. Let's do
Okay.
it.
So, and then there's one to like x squared. So if it's 2x squared over x is smaller than 1x squared, will it just be then? And then so 2x is smaller than x squared, and it'll be 0 is smaller than x squared minus 2x plus 0. And then it says x is smaller than 0 and x is greater than 2.
Greater than 2. I don't have the answer. I'm sure it's correct. X is smaller than 0. That will make it less than 1 because it's negative. And then x is greater than 2. So 2 will be exactly 1. Bigger. Yes, great. Let's see. One. Let's try question C.
Okay, so will that be like 1 over x is greater than minus 1?
Yeah, that's fine. 1 over x is greater than minus 1, and then you just go from there. How about D?
So so Do I need to times those by x squared?
I think do what you did in the previous one. Simplify it first.
So to do that, what I do 6 is greater than 8 over x minus 5 over x. So will it be 6 is greater than 3 over x?
Yeah, and then it's just the same. Let's do the last one, f.
Okay, and then so 6 over x squared plus 7x. So, do I need to times do I need to like minus 3 or something?
Yeah.
And so it'll be 6 over root. And then what do I then do? X squared plus x over 1 minus 3, or I'm not really sure what. Yeah.
Multiply everything by x squared.
So 6x squared over x squared, 7x squared over x, and then minus 3x squared, and then that'll give 6x. So will that then be minus 3x squared plus 13x plus 0 is greater or equals to 0?
No, simplify. What is 6x squared over x squared?
Oh, it's just 6.
Yeah.
So will it be minus 3x squared plus 7 plus 6? No, it's plus 7x plus 6.
Yes.
And so it says x is greater or equals to minus 2/3, and x is greater or equals to 3.
Great. Grand. Okay, yeah, so just multiply everything by x squared and simplify. All right, this one, let's try this.
Okay. So can I just do like x minus 3, the 2 brackets x minus 3 is greater than 5?
Yep.
And then will it be 5.5 is smaller than x?
So x.
Oh, sorry. No. 5.5 is smaller than x.
So x is greater than 5.5?
Yeah.
Let's think about this. So it needs to be less than 2. Yeah. I think there's another set of values though, because if it's negative, then it's also less than 2. So how could you do that?
So I then need to do something like 5 over x minus 3 minus 2 is greater than 0.
I just want to see. So we had 2x minus 6 is greater than 5. 2x greater than 11. What would you get if you multiplied both sides by x squared?
2x cubed is greater than 11. Oh, 11x squared.
11x squared. Okay. So how would you solve that?
Would you do 2x cubed minus 11x squared plus 0x plus 0 is greater than 0?
Yeah.
I got 11 over, yeah.
So x is greater than 11 over 2. Wow, that's what we got, isn't it? That's what we got. But hold the phone. Let me think about this. I'll leave it. Yes. Okay, how about this one?
Okay, so this is what have you got the discriminant here or something?
Yeah.
So b squared minus 4ac, and so will that be k squared minus 4 times 1 times k plus 3, and so that will be k squared minus 4 times k plus. So that would that be k squared minus 4k plus 12 equals to 0, and then I can just do the quadratic.
Slow down. Minus 4 times 3?
Minus 12.
So that's minus 12. And if it has no real roots, what do you know about b squared minus 4ac?
It's going to be smaller than 0.
Smaller than 0. And that's what you solve.
Yeah.
So question 8.
I got minus 2 is smaller than x, which is smaller than 6.
What was it, sorry?
Minus 2 is smaller than x, which is which is smaller than 6.
That's great. Sorry, this previous one. Multiply both sides by x minus 3 squared.
So x minus 3 squared
So it's the denominator squared.
So I'm confused as to what just happened.
Sorry, so I just went back to the previous question.
Yeah.
So the one after this was correct. We multiply both sides by the denominator squared. So this time the denominator isn't x, it's x minus 3.
Okay.
So I just multiplied both sides by x minus 3 squared.
Yeah. So do I need to then solve? Do I then need to? Oh wait, if I do the x, take the x minus 3 from the bottom and divide it by the one on the top, will it just be 5x minus 3?
Mm-hmm.
And so minus 3 is smaller than 2, x minus 3 squared, and then 5x minus 15 is smaller than x squared minus 6. So then do I need to do 0 is smaller than 2x squared minus 17x plus 33.
How did you get? Yep.
And so will that then be so x is smaller than 3 and x is greater than 11 over 2?
Yes. And so you had the first half, which was x is greater than 5.5, 11 over 2.
Yeah.
I noticed that this denominator, it could be minus 4 to get minus 7, and 5 over minus 7 will be a negative number, which is definitely less than plus 2.
Yeah.
You can't divide by 0, so 3 minus 3 you can't do, but anything less than 3 will work. 2 minus 3 gives a negative number, 1 minus 3, and in general x is less than 3 as well. Yeah, so multiply both sides by the denominator squared. Let's see. And exam question.
Okay, so it says it has no real roots. Do I have to do the discriminant here?
Mm-hmm.
So 2k squared.
Sure. Technically it's minus 2k squared.
Yeah, sorry.
You'll get the same thing. Okay, go
on. Minus 4 times 1
Nope.
times. Oh no. Oh, minus 4 times k.
Yep.
Times 3. And then that'll be 4k squared minus 12k.
Mm-hmm.
Plus 0 equals to 0. And then because it's no real roots, do I then need to do is smaller than 0?
Yes.
Okay. And then and then I got 0 is smaller than x, which is smaller than 3.
Just smaller than 3. Hold on. It has no real roots. It has no real roots. They're saying it could be less than or equal to 0. Why is that? The equation, this, where there's no real roots. If it has no real roots, then it's less than 0. No two ways about that. What are they playing at? Let's see this. Has no real roots using the discriminant. Sure. No, this is what they drew. So 0 is less than k is less than 3. When k is 0, the equation gives 3 is equal to 0. Well, that doesn't make any sense, so it shouldn't be included. Let's take a look. So they're saying that's 0. It can be 0. The equation has no real roots. Yeah, when k is 0, you get 3 is equal to 0. Which I suppose doesn't have a real root. Okay, so it seems like 0 is just a special number there.
Yeah.
And so for that one, 0, it could be 0 technically, so it's or equal to 0 because no real roots. 3 is definitely not equal to 0, so there's no solutions for that. When k is 0. Why did they throw in these curveballs like that? Do you know what I would do? I would say 0 is less than k is less than 3, and then I'd look at this and say, oops, they had or equal to, so I'll just make it or equal to.
Yeah.
That's what I'd do there. Okay, quadratic inequalities. We got it all done. X a half or tick.
I'd probably give it a tick.
Yeah, and with the quadratic inequality solver on the calculator becomes very easy. Without that, it's all graphs, and you have to do the graphs next anyway, so we're not skipping them. And you don't have a graphical calculator, is that right?
I probably will get one. Just that I haven't got one yet. They're pretty expensive. So
yeah. Yes. So, do you want to continue this next time?
Yeah. Yes, please.
Okay. Well, and how's maths going in school?
Hard. The people there are like really good at maths, so it's pretty hard. But yeah, I'm doing better here than I'm at school. So yeah.
And what are the other subjects you're doing?
Business, economics, and politics.
And how are those going?
Better. Yeah, better.
Yeah, A-level maths is one of the harder ones. All right. Well, any questions for me in general?
I don't think so.
All right. Well, well done, Andrey. You did great. I look forward to talking again next week.
Yeah. Thank you. Bye.
Have a good week. Goodbye.